amps, ppm, volt, and of course grams.
Here are the manufacturer data. I don't care about this one. We tested this one. There is only data for 3S voltage, and in 3S I only tested this one, this propeller, the 1045. And you see that according to the manufacturer at 9.5 amps you should get 642 grams of pull. So let's go. This is around 3.4 volt per cell. 9.5, you see it's between these two values, and we can say it's approximately 550. So data of manufacturers are too optimistic, like I expect. So let's take a look about the curve. You have the thrust in blue and the efficiency in red. You see that all values that are representative of what you will use during the flight, which is probably between 30 and 80, it's nearly along a straight line. And you find this logic with all the voltage and propellers, as you can see. I highlighted in green the values that are interesting at overing. If you are between this and this, you will have correct maneuverability and endurance. You see that the 1038 have better efficiency globally than the 1045. So we can send the gem fan type, the 1038, win the match in 3S, and anymore it have more maximum pull than the 1045. Let's go to 4S. So as you can see, the efficiency of the 8-inch propeller, the 8045, is catastrophic. I will never use this. In 4S 9-inch, the 9045, we have much correct efficiency than with the 8-inch. The efficiency is below what you can find in 3S. However, the pull is better. So in the range of what we can use, we are around 350 and 450, and in 3S maximum is 350. So we can globally say that you win a bit less than 100 grams, maybe 80-90 grams with the 4S voltage. So about the measure itself, you can see two red values. It's measure, and all what is between, it's estimation. Amps, the unit is explicit. I remove 0.05, as you can see, because it's you see it's idle consumption. It's the 5-volt BEC consumption. You can disconnect the BEC if you don't need, and so you can win or at least don't lose this consumption. The electric power in watt, which is just calculation between the resting voltage and amps. Thrust in gram, nothing to say, and efficiency in gram per watt, nothing to say also. As last thing, what I want to show you, this data is at 3.8 volt per cell, as I already told. But when you perform the same test at 4.2 volt per cell, you see that the maximum pull of the 9-inch is around 900 grams. So here is the difference between the maximum value and at 3.8, 3.7. I target 3.8 because I expect during test value will lower to 3.7, which is the nominal voltage of the battery, and is more representative of what you will get in flight. So it's really the 3.8 values that you must use. And how to use this? For example, for the in 3S with the 1038, you have at 50 and 60% of throttle, which are, we can say, nearly the ideal while hovering. A pull between this and this, so we can say roughly 350 grams. So, for example, for a quadcopter, and if your quadcopter weighs this, probably it will have a good endurance and maneuverability. Of course, if you are below, it could be better, but it's a good starting point. If you exceed this value, your maneuverability will reduce, and endurance can be affected also.